Hello class, this is the second video from today. We are learning ways to solve systems of equations. The first video was how to solve by graphing. And so you'll see number 2 I still have up here that was in video 1 and we solved for graphing. And so when we graphed y equals 5, that was the red line. And then we graphed y equals 2x plus 7, that's that blue line. And where they intersected was the solution, and it was -1, 5. Now I'm going to show you the same problem. I'm actually going to do the exact same problem, but I'm going to solve by substitution instead on this problem. And then we'll do a harder one also. So I'm actually going to just steal the same problem, y equals 5, and then y equals 2x plus 7. So we actually already know the answer. The answer is -1, 5. But we're going to try a different way, and I want to see if we get the same answer. Okay? And so substitution on page 2 of the class Kik, it does give you the step-by-step. And it says that you must isolate one of the equations with one of the variables, meaning one of the equations, the variable has to be by itself. And the variable can either be the y or the x. In this case, the y's are already by themselves. So we actually have both of them and we have some options, okay? And so this one says y equals 5. So I know what y is. Y is 5, okay? And so I can actually solve for x because I know what y is. And this is what we normally do. We just call this substitution. The reason this one's easier is because y is an actual number. And so we're used to doing this and we're used to solving. But you're going to see on the next problem we do, it's a little more complicated. So I'm going to substitute 5 into the other equation for y, because y equals 5, okay? So into this equation, I'm going to now get 5 equals 2x plus 7. And again, all I did was I substituted 5 in for y, because I know that y equals 5, okay? So now I can solve. I can say, okay, -7 both sides. And so I get -2 equals 2x. And then divide both sides by 2, and so x is -1. And so when y was 5, x was -1. So as a coordinate point, I got -1, 5, right? And we know that that's going to be a solution for both problems now. And so you'll see we got the same answer, and we didn't even have to graph it, okay? Let's try one that's a little harder, though. So if I go to the class Kik, and I go to page 2, okay, page 2 has a couple hints on here for you guys to do a few of them. Okay, I'm going to do number 11 with you. So number 11 is the one that I want to do with you. So let's write it down. We have 2y equals 6x plus 10. And then the other one is 3x minus y equals 5. And so remember, with substitution, the first rule is you want to isolate one of the variables. So for one of the equations, you want x or y by itself, and it does not matter which one. And so you and I might choose different ones, but you'll end up with the same answer, which is really neat. So I'm going to actually make it a little more complicated, and I'm going to solve for x, okay? Because x, I want you to see that you don't always have to solve for y, okay? And so I'm going to take the second equation over here, and I'm going to isolate x. So to isolate x, I need to add y to both sides. And so I get 3x equals 5 plus y. Okay, and then x is almost by itself. So now I need to divide everything by 3. And so I get x is equal to 5/3 plus 1/3 y. Okay? And so I've now solved for x. So x is all by itself. So I'm going to take the value of x, or this other equation that x equals, and I'm going to plug that in to x in the other equation. Okay? I'm going to substitute it. So I'm going to take this new equation, the 5/3 plus 1/3 y, I'm going to substitute it in for x because it equals x. So that's why we're allowed to do that. Okay? So I'm going to get 2y equals 6 times, and it's going to be this whole equation we just did. So 5/3 plus 1/3 y. And then we still have this plus 10 on the outside. Okay, so I want you to see that we took this equation and we just plugged it in for x because x equals that. Okay, now we're just going to solve for y because you'll see now everything has y in it, and so we can solve for y. So the first thing I need to do is I need to distribute. So I need to distribute this 6. Okay, so I'm going to get 2y equals, and then if you do 6 times 5, that's 30. And then 30 divided by the 3 on the bottom is 10. Okay, so if you did 6 times 5/3, you'd get 10. Okay, plus 6 times 1/3 y. Well, 6 times 1 is 6, the numerator. And then 6 divided by 3 is 2. So it's going to be plus 2y. And then I still have this 10 over here, so I need to bring this 10 down, plus 10. Okay. So now I'm going to do 10 plus 10. So I get 20 plus 2y, and then I get 2y. But look what happens. I'm going to subtract 2y from both sides. And so I'm going to end up with 0 equals 20. Well, 0 does not equal 20. So something's weird with this problem, right? And so the question's going like, well, what is going on with this problem? Okay. And so number 11, there's a couple ways we can figure out if we did something wrong. We can graph this just like we did earlier and see what happens, okay? So let's do that real quick, okay? I want to change that to slope-intercept form real quick. So I'm gonna kind of pause the problem we just did because something weird happened, right? And so we're gonna do 2y equals 6x plus 10, but we're going to change that into y equals. So all I have to do for that first one is divide everything by 2. So I'm going to end up with y equals, and then 6x divided by 2 is going to be 3x, and then 10 divided by 2 is going to be 5. So y equals 3x plus 5. Okay? So y equals 3x plus 5. That's when I divided everything by 2 on that first problem. And then the second problem is 3x minus y equals 5, okay? And so now I want to say, okay, let's change the second one into y equals. So I'm going to add y to both sides because I don't like negative y's. And so I'm going to get 3x equals 5 plus y. And then I'm going to subtract 5 from both sides. And so I'm going to end up with 3x minus 5 equals y. Well, that's very close to this. It's not quite the same, right? This one's 3x plus 5, and this one's 3x minus 5. But what we will notice is the slopes are the same. And if you remember, if a slope of a line is the same, then the lines are parallel. And so we can test this out real quick. We can actually graph it and see it. So we're going to do y equals 3x plus 5. And then my other one was y equals 3x minus 5. And you'll see that we get parallel lines. So remember, parallel lines never touch. So when we go back to what we had just done with the problem, when we were trying to do substitution, we got a weird answer. Our weird answer said that 0 equals 20. But 0 does not equal 20. That's false. This is false. And so when you get a false statement, something's weird is happening. And I just showed you why. But when you get a false statement here, because this is not true, you have no solution. And so you don't even need to continue on because it does not make sense. Okay? All right, let's try one more. So let's go back to the class kick. And let's try number 8. Okay? So number 8 by substitution. So it's going to be y equals negative 5x plus 30. And then the other equation is 7x plus 3y equals 42. And remember, the first steps is to solve for one of the equations for x or y. But you'll look, it's already, the top one is already solved for y. So don't make more work for yourself. We're going to use that one because it's already there. So we know that y equals this. Okay? And so since y equals that, I'm going to plug that whole thing into the other equation for y. I'm substituting it. Okay? So my equation on the right is 7x plus 3y. But instead of y, I know that y equals negative 5x plus 30. So I'm substituting that in for x. I'm sorry, for y. Okay? And then that's going to equal 42. Now I can solve. So I can distribute here. And so I'll be left with 7x. And we get a 3 times a negative 5x. So it's a negative 15x. And then we have a 3 times a 30. And so that's going to be 90 equals 42. So now I can combine like terms. Because these are both on the left side, I just combine like terms. Okay, so it's going to be 7x minus 15x. Okay, and so I get a negative 8x plus 90 equals 42. So now I'm going to subtract 90 from both sides. So I get negative 8x equals, we have a 42 minus a 90. 42 minus a 90 is going to be a negative 48. Divide both sides by negative 8. And we have a negative 48 divided by a negative 8. So a negative divided by a negative is a positive. So x is going to be 6. Okay. Now we're not done because the solution is always a point. So now that you know x, though, you can go back to the original equation. It doesn't matter which one. You can use either one. I'm going to use the one where y is by itself because now I need to solve for y. So I'm going to substitute 6 in for x and solve there. So let's use a different color so it's easier to see. Okay. So I'm going to do y equals negative 5. But then instead of x, I'm going to use 6 because now I know that x is 6 plus 30. And so I get negative 5 times 6 is a negative 30. And then I get negative 30 plus 30. And so y equals 0. And that's okay. Y can equal 0. And so this solution then is going to be x comma y. So it's 6 comma 0. And that's your final answer. That's where the two lines intersect, is at 6 comma 0. Okay, so hopefully this helped with substitution. The next video will be elimination.